So what is imaginary? Imaginary numbers are to deal with our favorite friend, the square root of -1, or negative anything. The square root of -1 is I. I is usually written in italicized, but it's not always, but just so you know, when you see that italicized lowercase I, that's usually referencing the imaginary numbers. That's the reason you rarely see I used as a variable in earlier math, a lowercase I. So there are some patterns with I. If I take I and I raise it to the first power, that is I. If I have I raised to the second power, that's -1. I to the third power is -I. And I to the fourth power is 1. This pattern is going to be used to help us with something here in a second. It's something you have to memorize. I to the 0 power is the same thing as I to the fourth. N to the 0 power is always 1. If I raise 1,350,000 to the 0 power, it's 1. So that's the reason to the 0 power it goes back to 1. So let's work a couple of problems. If I have I raised to the 33rd power, this looks like it's going to be an extremely difficult problem. What is 32 divided by, or excuse me, 33 divided by 4?
So is it 33 or 32?
33. It's not going to be a whole number. How many times will something go into it evenly? 8, giving us 32, with 1 for my remainder. So that means this is the same thing as I to the first. It always is I to the remainder. And then I use that page over here, what I told you have to have memorized, and figure out what would that translate to. I to the first is just I.
Do you always divide it by 4?
Always divide it by 4. Because it takes 4 before the cycle repeats. So if I have I to the 72nd, I'm going to take that 72. I'm going to divide by 4. It's going to go into the 7 once. Yeah.
Why are we always dividing by 4?
Because that's how many times it takes before the cycle can repeat. This is a always number. So we go into 72, or 7 once, leaving us 32. 4 goes in 32 how many times? So my remainder is 0. That means this is 1.
So
Yes.
if the remainder is 1, then that always means it's going to be I to the
First.
first power, and if it's 0, it's always going to be 1.
Uh-huh. If it's 2, it's always going to be -1. If the remainder is 3, it's always going to be -I.
Oh, okay.
So whatever your remainder is the power you look at in that first chart. And so let's do I to the 7th. And so we're going to take 7, we're going to divide it by 4, and that gives us 1 with a remainder of 3. So that means I go back to that first chart where I is 3. That means we have a -I. Oops, didn't go far enough. Which is -I. We cannot leave I with a power. I's power always has to be changed to where it's taken away. And the way you do it is the process I'm doing right now. And the other way we'll use it is if I have the square root of negative 25. Up to this point, I said you can't do anything. Now, we can deal with this. So, you're going to do an I at the end. What's the square root of 25?
5.
So, this is 5i. So, anytime you have a negative here, you write down an I outside the square root.
Is it always going to be negative or no?
It's always going to be negative. If it's positive, you don't have to worry about I.
Okay.
So if I have the square root of a negative 322, I know there's going to be an I involved. Because this negative is going to come out as I. How do I simplify that 322? What do we do
By
on
twos. Divided by 2.
divided by 2? So we're going to sit there and look and see what is my factorization. So I'm going to divide by 2. And that gives me 1, 6. And is 161 divisible by anything?
3.
No, it's not 3. I forgot the number I had originally, so. So it's divisible by 7, and that's divisible by 23. So there's no perfect squares for me to pull out. So it's, you write the square root first. Or you can write the square root at the end, whichever way you prefer. So this is the same thing as me writing I times 322. If you think your handwriting is going to get sloppy and your square root's going to get in the bad spot, write the second one.
So you just write this square root again?
You just write
without
it-
the negative?
Without the negative.
If you
So-
can't.
If you can't do it. So like if we had like the negative square root of 24, we know we're going to have an I pulled out. This is divisible by 2, which gives us 12, which is divisible by 2, which gives us 6, which is divisible by 2, and gives us 3. So I have here a set of 2's I can bring out,
Square root is-
and the square root of 6 that has to stay behind. So this is the same way we were doing before. If there would have been a negative on the original problem, then this would be negative. The negative outside the square root just goes with the negative for the answer.